Hello students, welcome to my YouTube channel Learn with Ali. So in the previous video, that is introduction part, we have seen some syntax in MATLAB and from the starting basics of the MATLAB. Then we have seen this program, that is how to plot a sinusoidal curve in the MATLAB. So in this video we are going to learn some plotting like this, some extra or some basic or elementary signals in MATLAB. So we are going to start from here. So first let's plot a signal, and we can say that signal is let's impulse signal. So we are going to plot impulse signal. So for plotting any signal, we have learned that we have to define the x-axis. So you know the impulse signal is 1 at 0, and other than 0 it is 0. So for example, so we want to see the signal from, let's say, -1 to 1 with a step size that is 0.001. In the previous, that is introduction part, we have this is explained well, that what is this starting point, and this is step size, and this is the last point. So we have defined the t for plotting the impulse signal. So for plotting the impulse any signal, for plotting we have defined t. So this t is the just x-axis. So now we have to define y-axis. For then for we are writing impulse, that is a variable, let's say impulse equals to. So for that, actually there is a several method to plot the impulse function in MATLAB, in which one method is to plot the 0 before 0 and 0 after 0, and at the 0 this is 1. So in that case we are defining an array which contains the zeros, that is there is a syntax in MATLAB which is called zeros, and this is let 1, 1000. So this is, before that let's comment this. Before that, let's run first this. So you can see how many points are in the t, that is in x-axis, how many points are there. So you can see when you run this, then this is t, there is 2001 point is there. So I am plotting, and this is 1000 points, it is 0, let's say 1000 0 before 0 axis, and then ones means it is a syntax in MATLAB which defines the 1, just gives 1. So 1 comma 1, that is only single one is there, and now again zeros. So we can define zeros as 1 comma 1000. So this is the vector, or you can say matrix, that contains the 2001 points. The first 1000 point is 0, and the 1001th point is 1, and again the last 1000 point is also 0. So by which you can this is the impulse. So let's plot this. For plot, you already learned how to plot the signal in MATLAB in the introduction part. So for plotting, let's t, and it is impulse. Impulse, let's plot this. So when you run this program, you can see there is a plot of impulse function. It is from -1 to 1, and this -1 to 1 came from this time axis t, and there is -1 to 0, this is 1000 point which is 0, and again at the 0 this is 1, and from 0 to 1 this is again 1000 point which is 0. So this is the simple impulse function which is generated by this method. So this, you can see this line is some thin, so you can increase the thickness of the line by using a command line width, which is a syntax in MATLAB. Let's say LINEWIDTH, line width. The default line width is 1, so you can increase, and the line width is as 2. And now if you are going to plot this or run this program, you can see the thickness of the line will increase. Let's say this is the thickness of the line increased. When you increase this from 2 to 3, that means the thickness of the line will increase further. So you can see this is more thicker than the previous one. So by this is the syntax, and in which the line width is increasing. So this is the plot. In the previous section, which is introduction part, we have not seen any labeling of the plot. So let's see in this video how to label. For example, X label. X means the X axis. What is the name of the X axis? That is defined in the MATLAB as X label, LEBEL, and the syntax can be written as this in this format. That let's define as X label is time. So I am giving some arrow point, and again, so just giving X label. Similarly, there is a Y label. What is the name of the Y label in the figure? That you can define in the MATLAB. So Y label can be defined as Y label, and which is let's, in this case I am giving it as amplitude, right? So Y label is amplitude. And similarly, there is another syntax in the MATLAB, which is title. So you can define the title of any figure in the similar manner. So this title is unit impulse. Let's define as title is in unit impulse. When you run this program, what you are getting, the x-axis should be written as time. Yes, see this, the x-axis time, and y-axis should be written as amplitude. Let's say this is amplitude, and title, which is unit impulse, this is the written as unit impulse. So by this way you can define the x-axis, y-axis, as well as the title of any figure. So let's see the second figure, which is let's unit step. So let's see, let's unit step function or unit step signal. How to plot a unit step signal in the MATLAB. So similar way we are just copying this. To plot any signal, you have to define the x-axis. For example, in the case of unit step signal, we want to see the signal from -5 to +5. Okay, so in the previous one it is -1 to 1, so we have seen the plot from -1 to 1. In this case we are just assuming that it goes to from -5 to +5, and let's decrease the step size from 0.001 to 0.01. So when we are just commenting twice, that means, and here let's also comment once again. So let's once again here also put, I want to show something to you that when you put double, generating basic signal in MATLAB, right? So actually so you can see that when you are placing a person here, it is just comment, but when you are placing a person, it is divided into sections. So this is the first section, this 3 command line, then this is the second section. I will show you, I will tell you what is the meaning of this and how we can use this section wise programming in this MATLAB. So let's see. First, unit step function, I have defined the t-axis from -5 to +5, and similar to the previous, let define a variable step, And let's there is a multiple I have said there is multiple way to represent any step signal. So first the previous one, same procedure. So let's say what is the step signal? It is 0 before 0 and 1 after 0, and at the 0 it is 1 or half, you can say, by Gibbs method. So let's define a similar to this zeros. Let's copy and paste here. So 0 before 0, when you run this, you can find how many points are there. So in T there is 1001 points, right? So you have to use 5500 points as a 0. So let's start. This is 0, so this is 500, it should be 500 points as a 0, then let 501 points as a 1 and close bracket. So this 500 plus 501, the summation of this two should be equal to the size of the T, otherwise it will give you an error. So this is the step. So let's plot this. So for plotting this, you know already how to plot. Let's plot, copy, I'm just copy pasting, copy, we plot T here, it should be a step, then this is 2. So when you run, so when you put double ampersand, that means it gives you the section wise. So you can run this section, you can run this section as well. So when you run on the whole, as a, for example, when you running this program, it will give only the unit step signal. See this is the only unit step signal, it is not giving the impulse signal. But when you run as a section, for example this section I have to run, then run section, there is a command I have explained run and run advance in the previous lecture, and in this video we are going we have seen that run selection means only this part you can see. So see, there is a -5 to 5 this graph goes, and thickness is 2, and this is 0 to 1. Let's increase the limit of the y axis. For example, y lim, you can say y lim equals, there is syntax that you can limit the y axis for the representation. For example, here I am limiting from 0 to 1.5. So this is basically the syntax. In a small bracket there should be large bracket where the y axis goes from 0 to 1.5. So let's again run section. You will see that y axis goes from 0 to 1.5, and this is 1. This is the unit step of the signal. So by this way you can plot the unit. And the second thing, if you, this is the blank, so if you want to see there is some bars or grids in this system, so you can write here just grid on, and you can see that there will be grid in the figure. So see this. So this is the second signal that we have seen. Let see the third one. So there is an alternate way to plot this step function. So let's see that how can other way we can plot. So by definition, if you have read the signal and system, then you can you know that a step signal can be defined in terms of the signum function. So we can write step equals to So what is the definition? That is 0.5 signum plus 0.5, or you can say signum plus signum t plus 1 divided by 2. So we can write as 0.5 so into signum. For signum there is a syntax in MATLAB which is called SIGN. This is signum function, and let's define t and plus 0.5. so this is the definition in the signal system by which you can plot the signum function also. So let's run this program. You can see you can expect the similar graph which we have plotted from the previous one. So let's say this is -1 to -5 to 0, and after 0 this is 1. This is the unit step function. So this by this way, this is the first method, and this is the, you can write here comment, second method. So let's write some other thing. There is a third one, let's say signum. So already we have defined how to plot a signum function. So some other signal. So let's plot a ramp signal, for example, a ramp signal. So similar to the way you can that the ramp signal is for this, for the x-axis t equals to, we are going to define from 0 to let's up to some positive value which is 10 or 6, 10, 8. Let's take 6, but with a step size 0.1 up to 6. And this is the x-axis, so you have to define y-axis, that let's define it as a ramp. And the ramp is same as t. This is the signal system definition of the ramp function. So now you can plot similarly as a unit step signal. Here you have to write a ramp, right? You can see this is from going from 0 to up, and this is x-axis is from 0 to 6. So this is the amplitude is same, that means this angle is 45 degree. For ramp signal, the y equals to t, the definition of the ramp. So at x equals to 1, y should be 1 at this point. At 0.9, 0.9, any point, what is the x value and what is the y value, it will be same. For example, here this is 2.9 and y value is also 2.9. If you can click here at this point, here it is 4.9 x value and y value is also 4.9. So this is a ramp signal. So this is some basic signal generating in the MATLAB. Let's see another signal. For example, here it is a rectangular pulse. A rectangular pulse, you can define the rectangular pulse as, this is same, you have to define the t-axis. So let's copy paste, and a rectangular pulse is, for example, I want to see that -1 to 1. So -1 to 1, and with a step size of 0.01. Let's take a step size of 0.01, and there is many methods, alternative methods to plot the rectangular pulse, in which one is that is inbuilt in the MATLAB, which is rect pulse. So when you are defining rect pulse, so you have to define the width of the pulse. So for example, here -1 to 1, so width will be, let's wi width equals to, let's 2, right? So to use this inbuilt function, which is y equals to rect pulse, rect PULS. So this way, this is the syntax of the rectangular pulse generation. here you can write rect pulse t, comma, so you have to give here some time and as well as the width. So width is 2, so you can write here also width, right? So my MATLAB is some lagging, I don't know why. So this is the width. So you can plot t comma y. So plot, why this is so slow? Plot t comma y, and let's run this. I don't know why it is. So let's run this section. In this way you will get, this is slow, why? MATLAB is not responding, I think. So you can see I have increased the x-axis from -1 to -5 to 5, and width equals to 2, y equals to rect pulse. It is the inbuilt syntax in the MATLAB for plotting the rectangular pulse, where t given by the x-axis and width is given by this defined by width. And let's plot t comma y, line width equals to 2 as already I have discussed, and y limit we have just proper seeing the value of y, we have limiting the y axis as 0 to 1.5, and this is grid on as already here explained, same thing. So let's run this section. So you can see there is a -5 to 5, and width of the signal, which is a rectangular pulse, is from -1 to 1, which is 2. If you increase the width as, for example, here 3 or 4, you can get the wider. This is -2 to 2, this is total 4, the width is 4, so you can get the wider. So in this video, let's close here video here. We will meet in the next video with some other elementary function or some other things. So if you like the video, please like, share and subscribe my channel.